Okay, I think you are really going to struggle if a question like this comes up on your paper. There's a lot of A-level maths in here, which is just really difficult to work through. There's a rule. Finding f dash is called differentiating. So this is asking us to differentiate this function f of x, and it's asking which one's true. The first thing to know about differentiation is if you have a polynomial, so if you have an x to the power of something, so like an x to the power of 4, then when you differentiate it, sorry, I've written a y there, you can write y or f of x, it means the same thing. I'll do f of x because they've done f of x in the question. There's a rule that says to do something called differentiating, which is it's about finding the slope of a curve. So it's about finding the gradient function of a curve. So to differentiate, the rule is that and we write it like that, if we differentiate a dash, you move the power to the front of the x, and then you take the power down by 1. So x to the power of 4 would turn into 4x cubed. X squared, if you were to differentiate x squared, you'd get 2 at the front, so you'd bring the power to the front. The 2 would turn into a 1, so it would be 2x to the power of 1. Now because it's a 1, we don't need to write it down, so x squared would differentiate to 2x. Now the other thing to know is that when you differentiate other functions, so you base lots of your differentiation on that, but you can differentiate other things using something called the chain rule, which is if I don't actually have x squared written in here, say I have, an x term to the power of 4 like we had before, if I have something else written in here, then the chain rule says that we pretend this thing here is an x and differentiate it as if it was an x. So we bring the power to the front and we take 1 off the power. But then you multiply by the differential, so the differentiated version of what you pretended was an x. Now if you were to differentiate 3x, the power is already 1. So the differential of this is just 3 times 1. So here you would just times by 3, okay? So the answer to this one would then be 4 times 3 times 3x cubed, so 12 times 3x cubed. Now that's what's going on here. We don't have an x, we don't have an x squared, we have a something else, and in this question it's log to the base 5x squared. So the first part of the answer to this question is, so if the question is log to the base 5 of x squared, you would bring the power to the front and take 1 off the power, so the power would go down to 1, and you'd pretend this is an x, so you just have the same thing again. So that's the first part of the answer. Now at this point you could guess the answer is A, because that is the only question, the only answer with that in as part of its answer. But what we should do is we should carry on and then multiply by what you get when you differentiate log to the base 5 of x. Now you're going to just have to learn this rule if you want to be able to answer this type of question. It's going to be really difficult for me to explain why the answer for the differentiation of this is what it is in such a short space of time. But if you were to differentiate log to the base 5 of x, the answer is 1 over x times it's called the natural log, ln, of 5. Okay? So, if we were to times these things together, when you times fractions and one's not a fraction, you can make it a fraction by making it over 1, and then we can times the tops together, so we get 2 times the natural log of 5x, 2 times log to the base of 5 times x times 1 over 1 times x times ln 5. Now we don't need any of the ones, we can ignore the ones. And rather than write x times natural log x, we can just write x natural log 5. So the answer is A. But as I said, a really difficult question. If you remember the first part of the rule, I would maybe have just done that part of it and then gone straight away for the A. I think it's very difficult for you to learn this other rule. The generalization of that rule is if you have a function. So we sometimes write y, sometimes we write f of x. They've written f of x, so I'll write f of x. Is if you want to differentiate any base, so I'll use an a again like I did on the other question, of x, then the answer, the differentiation of that, is 1 over x and then this ln a. Okay, this means the natural log. This is called a base, and when a base is something called e, we write natural log instead. So that's what that means. But as I said before, it's going to be too difficult for me to go into that and for you to understand it in the time that we've got. Maybe learn this rule here, and then if you have that in another question, you'll be able to just use the rule. So for example, if we'd had log to the base 7 of x for f of x, then the answer would be f dash x is 1 over x ln 7. Okay, maybe just learn that rule in case that question comes up. And then if we apply that to the two-step of it, so if I make a new question similar to this one, say we had f of x is equal to log to the base 6 of x cubed, then we can use that thing called the chain rule first, where we pretend this is an x and differentiate. And remember, for that we bring the power down to the front, keep that as it is, take 1 off the power, and then we're going to times by what we pretended was an x. We're going to times by the differentiation of this, which we just said was 1 over x ln 6. Okay, and then we would, as I did before, pretend this is a fraction over 1, multiply the top and multiply the bottom. So we'd end up with 3 log to the base 6 of x squared over x ln 6. Okay.